Kia ora koutou. This video is for my Year 11 class because we're going to learn how to solve simultaneous equations over the next couple of lessons. So this video goes through one of the two main methods, which is called the substitution method. It's usually the one that students find the easiest to start with. But it's also revision for students in Level 2 Calculus, and this particular set of questions is a request from Joe. So what I've got here are 4 examples from Mr. Black's Level 2 Algebra textbook. So if you're watching this from 12 MAC, you might recognise some of these examples. So what we've got when we've got simultaneous equations is we've got usually when we start out, two equations that have got x and y in them. So I'm going to just look at the first pair of equations we've got here and see what's going on with them before we get going. Well, you can see that in this one here, we've got y is equal to negative 2x plus 5. That looks a lot like what we saw back in Year 9 for the equation of a straight line. And then the other equation has also got x and y combined, but not written in that same way that we had in Year 9. Okay, so what we want to learn to do this year is to find the x value and the y value that make both of those equations true at the same time. Okay, so I'm going to give you another example going further back. Suppose that I had y equals 2x plus 1, and I had y equals negative x minus 3. So we could draw those two lines. We're not going to do this much in this topic, but we could start out by thinking about it like that. Right, so if we just chuck some axes down and very roughly sketch these. So 2x plus 1, this first one here, is going to have a y-intercept of 1. Let's just rule it up a little bit accurately. So here's 1 here. This is not going to be very accurate, guys, but it's just to give you the idea. So 2x plus 1 is going to be a straight line that goes through the y-intercept of 0, 1. And this equation here, y equals negative x minus 3, is going to have a y-intercept down here. Oops, something weird's going on with the laptop. Hang on, guys. Something funny's happened. Sorry. There's a couple of pixels on my OneNote that glitch out. And I just hit one of them. Right, here it comes back. Okay, here we are down here. Right, let's try again. So we've got the first line drawn, which is y equals 2x plus 1. And now we're going to draw this one. So we've got negative x take away 3. So the y-intercept is down here, and it's got a gradient of negative 1. So that line is going to look roughly, let's see if we can get a 45-degree angle. Something like that, right? So when I'm solving simultaneous equations, what I'm saying is tell me the x and y combination that make both of those things true at the same time. And when I've got y equals this and y equals this, we do it by setting those two y values equal to each other. And you can see that here we're back to solving x on both sides. All right, so we'd go from there. But when we've got them in this format, it's not quite as obvious to see where we should start. So the method that this video is going to do is called the substitution method. And what we've got is these two equations of straight lines. So the first one, 2x minus 3y is 17, gives us a link between x and y. And then the second equation is this one here, which says that y is equal to negative 2x plus 5. So for those two things to be true at the same time, in the second equation, y must equal negative 2x plus 5. So that must also be true in the first equation. And that's what the method of substitution is all about. So I'm going to work through those now, and we'll see that they gradually crank up in difficulty. So we have 2x minus 3y equals 17. And then the second equation is that y equals negative 2x plus 5. So we're going to take y equals negative 2x plus 5, and we're going to substitute it in where we see y in the first equation. I'm going to call that one equation 1 and that one equation 2. And you'll notice that we use all of our skills from year 9, expanding brackets and collecting up like terms. So we can write this. Now I'm going to expand those brackets and then have a look at what we've got. So we've got 2x plus 6x minus 15 equals 17. Collecting up like terms gives me 8x, and then adding 15 to both sides gives me 32 here. Solving that gives me x is equal to 4. Right? So that's great, but that's not the whole thing, because we also need to work out now the y value that makes them both true. To do that, we're going to substitute it back in here, and we get y is equal to negative 2 times 4 plus 5, which is negative 8 plus 5, negative 3. So a nice thing to do at the end is to write that the x-y combination that makes those two equations true is 4, negative 3. Okay, so that's the first one. If you're watching this and you're in either 11 MAT with me this year or you're in 12 MAC, I'd like you to make sure you've got that example written up nicely in your book. Now I'm going to go on to the next 3 pairs of simultaneous equations. Let's take a look at this one. Well, we've got x plus 7y is 15 for the first equation. And then for the second, we've got 2x plus y is equal to 4. So you can see this one is a little bit harder than question number 14. Let's just look at why that is. It's because of how the information is presented. So I'm going back to question 14, we've got the first equation, and then in the second equation, y is the subject. So we know that y is equal to blah, blah, blah. As we move through these examples, it's our job to make either x or y the subject of one of the equations. So what I've chosen to do with the second one is I'm going to work with equation 2, and I'm going to rewrite it to make y the subject in here. So let's now slowly go through how to do that. So equation 1 is x plus 7y equals 15, and equation 2 is 2x plus y is equal to 4. Now there's another way that we could do this. This video is about the substitution method. So I notice that I've got y on its own here. That makes it very easy to take the second equation and make y the subject. So y is equal to, I'm going to make it negative 2x plus 4. Now we take this and we substitute it in here. For some of you watching, it's fine if you'd gone y equals 4 minus 2x, because they are the same thing. Right, substituting that in to equation 1, we get x plus 7 times negative 2x plus 4 is equal to 15. Expanding gives me x minus 14x plus 28 equals 15. Negative 13x equals negative 13. So x is equal to negative 13 over negative 13, which is 1. So that's my x value. Next up, I need to take that x and work out my y value. So y is equal to negative 2 times 1 plus 4, which gives me negative 2 plus 4, which is 2. And we can write the ordered pair, x, y, as 1, 2. Okay, so the next couple of equations follow a similar pattern. Let's just take a look here at what we've got. This first one, we've got x plus 2y is 5. And in the second equation, we've got 0 is equal to x minus y minus 1. So we have some choices we can make here about how we do the rearranging. For me, what I noticed first is that I've got x here and all of this. So I'm going to make x the subject in that one. So I want you to pause the video and see if you can get through this one on your own. Note that the solutions will have fractions. Do not write them as decimals, okay, because then they're recurring decimals. So please write your answer with improper fractions. Okay, so it goes like this. X plus 2y equals 5. And then 0 is equal to x minus y minus 1. I'm going to take equation 1 and I'll write x is equal to 5 minus 2y. I'm going to take this and I'm going to substitute it into here. We get 0 is equal to 5 minus 2y minus y minus 1. Cleaning that up, I get 0 is equal to 4 minus 3y, giving me 3y is equal to 4, or y is equal to 4/3. Now, I can't remember if this has happened already, but in this case, notice that we're getting the y value first, and now I'm going to substitute into here and get my x value. So x is equal to 5 minus 2 times 4/3. Getting confident with fractions, 15/3 minus 8/3 leaves me with x equals 7/3. So my solution, my pair of xy values is 7/3, 4/3. Okay, so that's that third one done. One more to go, and just in time, because I think we're going to run out of video recording. Plus, you're probably all getting pretty bored at this point, but never mind. Right, what have we got? We've got another pair that's going to give us slightly icky fractions as solutions. Again, let's just start by having a look. So in the first one, we've got 3x equals 3 plus y. And in the second one, we've got 2x plus y equals 5. I could choose easily to make this y the subject and then substitute, or I could work on this one. I did the y out of here, but you'll get the same answer either way. Right, let's just get some clean bit of whiteboard. Right, 3x is equal to 3 plus y, and 2x plus y is equal to 5. Taking this one, rearranging gives me y equals 5 minus 2x. I'm going to take this and I'm going to substitute into equation 1. 3x is equal to 3 plus 5 minus 2x. Cleaning up, we get 5x equals 8. So x is equal to 8/5. I now take this x and I get my y value. So y is equal to 5 minus 2 times 8/5. Getting a common denominator gives me 25/5 minus 16/5. So y is equal to 9/5. My final combo is x, y is equal to 8/5, 9/5. So there you go. Thanks for watching. Joe, thank you for sending in that request. Guys, please keep the requests coming. It is really, really good to ask for help so that you're using the time you've got in class and the independent time that you've got at home. Let me know if you've got any more that you want done.